started. So I'm going to be going over a problem that's similar to what's going to be on your assignment and the lab that we do on Wednesday. And so I kind of want to go through stoichiometry step by step, since I know some of you guys are still having a little bit of trouble with it, which is fine. But again, this is one of the last times I'm going to go through it step by step in class. Okay, going forward, there's not going to be a lot of times where I go over all the parts, balancing, molar mass, everything like that. I'm expecting you to know it. Again, we've been doing this since October, so it should be pretty simple by now, okay? Okay, so if you're having trouble with any of the parts of Stoic, make sure you're following along. Let me know if you guys have any questions. And again, this is recorded, so you guys can always refer back to it. Okay, let's get started. So you have an equation right here. And if you guys notice, there's no numbers in front of the chemicals, right? So that means we need to balance it. So let's start by balancing this equation. What you want to do is you want to write down the elements that just every single element that we have. So it's the capital letter. So we have H and then lowercase g. So this is an element. We got HG and then we got O. So that's going to be the other one. Okay, so this equation only has two elements inside of it. Okay, and again, we're looking for the capital letters. Okay, and again, if you guys know how to do this already, you can just kind of go ahead and finish it on your own. You will be turning this in for credit, so just make sure you guys are following along. All right, so if we want to count up the elements, we need to look at the small numbers. So here, there's no numbers next to these, so we got one of each. So we have one Hg and one oxygen. And then if you look on the right side, we have one Hg. And then if you notice, there's a 2 next to oxygen, so we got 2 oxygens. So that's going to be the initial count for our balancing. Just want to start off by counting the small numbers, and that's going to give us how many we have on each side. All right, now there's 2 rules for balancing. The first rule is you want to add to the side with less. Okay, we want to add to the side that has fewer of that element. So if you guys take a look at the equation, which element is not balanced? Yeah, oxygen. Okay, which side has more oxygen, the left or the right? Yeah, so we want to add to the side with less, so we want to add to the left side. And that's where the second rule comes into play. We want to add the whole molecule. You can't just add the one that you need. You want to add the whole molecule. So we're going to add HgO. Okay, you can't just add Hg, you can't just add O, you have to add the whole thing. Now, if we do that, we're going to change up our numbers a bit. Okay, now we don't have just one, we're going to have 2 Hgs, right? 1, 2, and we have 1, 2 oxygens. And so we have 2 oxygens on both sides. And then last thing we need to do is balance the Hgs. Okay, so we're going to add an Hg on the right side. We can add this one by itself because it's just one element by itself. So now that's going to give me 2. And there you go. We have our balanced equation. All we need to do is put a 2 in the front here and 2 in the front here. And that's going to be how we balance. Any questions on the balancing? Okay, again, you are going to be turning in these notes for points. Just make sure you're following along. Let me know if you have any questions. I'm just going to grade them real quick and then have them back to you so you can refer back to it while you're doing the assignment. Okay, so that's step 1. Okay, now let's look at the problem. It says it's asking us how many grams of gaseous product will 12 grams of HgO decompose into. Okay, so if we got a number next to a chemical, we know that that's usually going to be our starting number. This is what we're starting with. Okay, so we know this chemical is important. Okay, it's asking us for gaseous product. Now, if you guys remember, products are the chemicals on the right side. Okay, so if you look on the right side, Hg has an L next to it, which means it's a liquid. So we're not really interested in that one, but O2 has a G, and G means gas. So this is the one that we're looking for. We are looking for O2. Okay. Makes sense why we're looking for O2? All right. So what we need to do now is we need to find the molar mass of these chemicals, the two important ones. HGO is important, and O2 is important. So we're going to go to the periodic table, and we are going to find their molar masses. Okay. So let's pull out our periodic tables. So we're looking for HGO first. So HGO. HG is kind of in, yeah, so HG is kind of in the middle bottom area. HG is 200.59. So we're going to put 200.59. HGO is made out of HG and O. So we look for O, and O is going to be 16. So we're going to do 200.59 plus 16, and HGO is 216.59. All we need to do is we just need to add up the elements. So HGO is 216.59 grams per mole. Hopefully not too bad. And now I'll give you guys a minute to really quick find the molar mass of O2, the other important one. This one should be pretty easy. Take a minute, calculate it, double check with your partner, and then I'll give you the answer in just a second. Yeah, if you can finish it, go ahead. Alrighty, guys. So O2 should be really easy, right? How much does one O weigh? 16. So if we have two of them, we just need to multiply that by 2. 16 times 2 is 32. So it's going to be 32 grams per mole. Okay, so that's the molar mass. Yeah.
So actually, you can't be more than here, right? Or is the opposite?
Actually, it has to be smaller.
So actually, okay, cool. That's what I'm saying. It cannot be more than here.
Alrighty, so let's do the stoichiometry now. Our starting number is the number that we're given, 12 grams. We're going to write down 12 grams of HGO. And then we're going to do our stoichiometry. So we're going to set up 3 fractions. Okay. All right, since we're looking for the gaseous product, we're going to put that at the very end. We're looking for O2, so we put O2 at the very end. So we're starting with this chemical, and then we're trying to end with this chemical right here.
Is this the only question?
That we're going over to this one. Okay, and then the top, so we're going to do gamma. So grams, moles, moles, grams. And then the little tricks that I gave you to help with stoic, the first 2 are about the same chemical, and the last 2 values are about the same chemical. So the first 2 are going to be about HGO, and then the last 2 values are going to be about O2, what you're looking for. Okay, so you're going to have to just memorize that. It'll kind of help you set up the fractions a little bit easier.
Sorry.
All right, your numbers for the first fraction come from the molar mass. The second fraction comes from the balanced equation. And then the last fraction comes from the molar mass. So those are just some things I recommend you memorizing just to kind of help out with setting up the fractions. But now we can start plugging things in. Okay, we're going to try to get rid of grams of HGO. So we're going to put that on the bottom. We're going to get the numbers from the molar mass. We found that it's 216.59. So we're just going to plug this in here. We're going to put 216.59 on the bottom because if you notice, molar mass is next to grams, and it always has to be 1 mole. So that's going to let us cancel out the grams. From there, we're going to cancel out the moles of HGO. Okay, so here we get the numbers from the balanced equation. So if you look on the balanced equation, HGO has a 2 next to it. So we're going to put a 2. O2 does not have a number, and that's going to be 1. So we put a 1 on the top. Okay. And then lastly, we're going to put moles of O2 on the bottom. Molar mass of O2, we said is 32. And we got to put the 32 next to grams and 1 mole. And there you go. That's going to be our stoichiometry with everything set up. So if I'm just being honest with you guys, this should be pretty simple by this point. But I know some of you guys are still learning Stoic, which is fine, which is why I'm going over it. But please make sure you guys understand this, because if you don't, you're not going to be able to finish the pre-labs. You can't do the labs, and then it'll kind of bite you in the butt once we take the exams as well. Okay. And this is the reason why we keep practicing Stoic, just because this is all we're going to be doing for the rest of the year. Okay, now let's start plugging this into the calculator. So remember that the rule is that all the numbers on the top, you're going to multiply, and all the numbers on the bottom, you are going to divide. So if you take a look at these numbers, we start with 12. 216 is on the bottom. So what do we have to do with the 216? Divide. So we're going to do 12 divided by 216.59. 2 is on the bottom, so we're going to divide. And then 32 is on the top, so we're going to multiply. So you can literally just punch this into your calculator, just multiplying the tops, dividing the bottoms, and that'll give you your final answer. So if we punch that into our calculator, we got 12 divided by 216.59 divided by 2 times 32, and that will give you a final answer of 0.886 grams of O2. And there you go. That's how you do stoichiometry. It's the hardest part of the assignment. Okay, so that's the answer for number 1. Any questions about that before we move on? I'll leave it up here since I know some of you guys are still copying this down. All right, but one thing I do want to mention is last time we met, we talked about theoretical yield, actual yield, and percent yield, right? Does anyone remember what this number is out of the 3? What number is this? Is this the TY, AY, or percent Y? TY, thank you. Yeah, all the numbers that we get from the math will be your TY, the theoretical yield. So whenever you do your math and your calculations, that number that comes out at the very end will be TY. Okay. Anyone still need this up here? Okay, yeah, just another minute. So quiet. All right, ready to go? Okay, so just make sure you have this number somewhere, 0.886, because that's going to be your TY. All right, so we said the theoretical yield was 0.886 grams. Now it says that if you ran this reaction in a lab and made 10 grams of Hg and 0.5 grams of O2, what is the theoretical, which we got? The actual and the percent yield. Now the actual is whatever we make in the lab, right? So in this problem, we're talking about O2. So what's the actual yield of O2? Yeah, 0.5. Thank you. 0.5 grams of O2. I know there's 10 grams of Hg, but we didn't do any math for Hg, so we don't really care about it. We're looking for the gaseous product anyway, and Hg is a liquid. Okay, so we got our Ty, we got our Ay, and when you do the lab, next time I see you guys, it's just whatever you make in the lab. And then the percent Y is very simple. The formula for percent Y is AY divided by TY times 100%. Okay, so we just need to plug it into this equation. So our AY is 0.5, so we're going to put 0.5 on the top, divided by 0.886 times 100, and that is going to give you your percent Y. So let's punch that into the calculator. We're going to do 0.5 divided by 0.886 times 100%, and that's going to give us a total of 56.433%. And this is going to be our percent Y. Okay. All right, and there you go. That is going to be it. That covers everything that you'll need to know to do the lab next time. Yeah, what's up? 0.5 is the AY. It's the one that's given to us right here. Yeah. So today I give you the numbers and the problems, but then next time we see each other, it's whatever you make in the lab. Yeah. What's up? Go ahead, just sign out. Alrighty, so like I said, I am going to be checking these for credit. So I'll give you guys another minute or two to finish copying it down. But if you guys are done, just come see me real quick before you start the assignment. That way I can give you credit for it. And then you guys can take it back to your seat, all right? Just hold on. Good, thank you. Good. Thank you. Thank you. Thanks, so. Wow. No, just show it to me real quick. Yeah, so just make a quick trip with me to me.